You're asleep, completely out, drooling on your pillow, probably snoring, zero awareness of the world around you. You are, by every biological definition, helpless. Now imagine you're not in your bedroom. You're in a tent, a thin piece of nylon, embarrassingly thin, separating you from a forest full of animals that could absolutely end you if they felt like it. Lions, bears, wolves, leopards, creatures that can hear your heartbeat from across a clearing, smell you from a mile away, and see 7 times better than you in the dark while you're just lying there with your eyes closed. And yet you wake up in the morning, every single time. Why? Here's what makes this genuinely strange. A sleeping human is the most vulnerable large mammal on the planet. You have no claws, no armor, no natural weapon. Your night vision is nearly non-existent. A leopard can see roughly 7 times more clearly than you in total darkness, because its eyes contain a structure called the tapetum lucidum, a reflective layer behind the retina that bounces light back through the eye for a second detection pass, essentially doubling available light. Humans lack this structure entirely. You evolved as a daytime animal, and your night vision reflects that. You are functionally nearly blind compared to any large cat in the dark. Bears can smell you from over a mile away, with a nose approximately 7 times more powerful than a bloodhound's and roughly 2,000 times more sensitive than yours. Wolves can detect your scent from up to 1.5 miles under the right conditions. Every one of these animals is physically capable of killing you in seconds, in silence, without you ever registering it was coming. So why don't they? The easy answer is that they're afraid of you. That's true, but it's the smallest part of the answer. The real explanation is a layered system of biology, chemistry, evolutionary memory, and behavioral economics that goes back millions of years. It's not one thing. It's never just one thing. There are at least 6 interlocking reasons, each stranger and more fascinating than the last. Together, they form something that looks almost like an invisible agreement between humans and the wild, an agreement nobody signed, nobody negotiated, an agreement written entirely in survival and encoded directly into the nervous systems of every large predator alive today. Start from the deepest layer. You are genuinely terrifying to them, not because of what you look like right now, but because you carry something they cannot see and cannot ignore, a 2-million-year record of killing. In 2021, researchers at Tel Aviv University published a study in the American Journal of Physical Anthropology. They analyzed the isotopic signatures of prehistoric human bones, the chemical fingerprints that reveal what ancient humans actually ate across an enormous span of evolutionary time. What they found was remarkable. For approximately 2 million years, the dominant diet of the human lineage was more than 70% animal-derived, not omnivorous, not opportunistically carnivorous. Hypercarnivorous, apex predator-level consumption sustained across 2 million years, longer than most modern predator species have even existed in their current form. That is what you are descended from. Not an animal that occasionally hunted. An animal that was, for 2 million years, one of the most effective killing systems on the planet. And the predators alive today are descended from the ones that survived contact with those ancestors. In 2017, researchers Justine Smith and Chris Wilmers at the University of California, Santa Cruz ran an experiment in the Santa Cruz Mountains. They played audio recordings of human voices near mountain lions, also called pumas or cougars in the wild. Normal human voices. People just talking. In 83% of the 29 experiments conducted across 17 individual animals, the pumas fled, not toward the sound, away from it immediately. Mountain lions that take down full-grown deer without hesitation. Animals that can drag a kill up a steep hillside. They heard a recording of people talking and ran. It gets more significant. When the researchers played human voice recordings near kills, prey the pumas had already hunted and were actively eating. The pumas reduced their feeding time by approximately 50%. Half their mealtime disappeared because humans were audible nearby. From a survival standpoint, that is a serious cost. A predator forfeiting half the caloric return from a hunted expended energy and risk to complete. And they still did it, because the discomfort of being near humans outweighed the nutrition. That result confirmed something biologists had been observing across multiple continents for a long time. Lions in Africa's Kruger National Park reduced their movement in areas of higher human activity. Tigers in India give wide berths to villages even when those villages sit in the middle of prime habitat. Jaguars in the Amazon have adjusted their movement patterns to avoid locations where humans are regularly present. These aren't animals that are physically incapable of attacking. They're animals that have decided at a species level over thousands of generations that being near your kind is not worth it. And the reason for that is one of the most important facts in natural history. Your species has been hunting and killing large predators for so long and so effectively that you have literally shaped their genetics. Think about the scale of that. Your ancestors hunted megafauna off entire continents: giant sloths, woolly rhinos, saber-toothed cats, cave bears. Species that had survived multiple ice ages vanished within thousands of years of humans arriving in their territories. In North America, humans hunted wolves to near extinction across most of the continental landmass. They eliminated mountain lions from the entire eastern half of the continent. They shot and trapped and poisoned apex predators so systematically for so long that the ones alive today are the descendants of the animals that were most careful around them. That is natural selection operating in real time. The predators that approached human camps too boldly got killed. The ones that preyed on human settlements got hunted down. The ones that kept their distance, that treated humans as something to avoid rather than something to engage with, survived. They reproduced. They passed that inherited caution on over thousands of years and thousands of generations. That caution became biological. It became instinct. It became the baseline behavior of every large predator alive today. When a leopard picks up your scent in the night, somewhere deep in its nervous system, a very old signal activates. Not a thought, not a conscious decision. An ancient, wired-in, inherited response that says, "Do not engage with that thing. Move on." That signal has been inherited from every ancestor of that leopard that survived a close encounter with humans. It is a biological memory passed down across thousands of generations, and it runs 2 million years deep. Now, let's talk about your smell. You've probably never thought seriously about how you smell, because you're surrounded by other humans all the time, and you've normalized it completely. But to a predator operating with a nose anywhere from 10 to 100,000 times more sensitive than yours, you are broadcasting an enormous and deeply unusual chemical signal. Bears have a sense of smell roughly 7 times stronger than a bloodhound's and approximately 2,000 times stronger than a human's. Wolves can detect scents from up to 1.5 miles away under optimal conditions. Big cats have a specialized structure called the Jacobson's organ, located on the roof of their mouths, that functions alongside the nose and essentially lets them taste the air, analyzing chemical information at a level of detail you can barely conceptualize. When these animals encounter a sleeping human, they receive a flood of olfactory data, and much of that data is wrong. Deeply, confusingly wrong. You smell like synthetic fabrics. Nylon and polyester and whatever industrial compounds were used in manufacturing the tent and sleeping bag around you. You smell like processed food, the meal you ate hours ago. You smell like soap and shampoo and sunscreen and insect repellent, a cocktail of synthetic compounds with no analog anywhere in the natural world, no template in any predator's sensory memory. And underneath all of that, underneath the layers of modern human life, you smell like a primate, which is something but definitively not the right thing. Not the deer or the wildebeest or the elk that these predators have spent millions of years learning to recognize, track, and hunt. There's another layer to the chemical signal that rarely gets discussed: your stress response. When you're anxious, when you hear something move in the dark and your heart rate climbs, your body releases adrenaline and cortisol. Research has shown that animals detect these compounds in sweat and respond to them. Not with aggression, with heightened alertness and avoidance. Your fear, ironically, makes you smell more dangerous. A human lying still in a tent, emitting a cocktail of unfamiliar synthetic chemicals and primate markers, is already strange to a predator's sensory system. A human whose chemistry is actively broadcasting alarm adds another layer of wrongness to the signal. For an animal trying to minimize risk, strange and alarmed is the last combination it wants to engage with. A predator's hunting instinct is not a generic drive to kill. It's a finely tuned system calibrated to specific prey. A wolf's predatory response is triggered by the movement patterns and scent profile of ungulates. A lion's strike mechanism is activated by the shape, speed, and smell of prey it has encountered thousands of times. You don't fit any pattern in the system. You are an anomaly, and anomalies in the wild trigger caution rather than aggression. Now, let's talk about fire. Fire produces something close to a universal fear response across virtually all land animals. It's not learned. It's not something animals figure out from experience. It's innate. Animals that were afraid of fire survived wildfires. Animals that weren't didn't. The avoidance behavior is so deeply embedded that laboratory-raised animals who have never encountered fire in their lives show clear avoidance responses to the smell of smoke. The fear runs below the level of individual experience. It lives in the genome. Humans began using fire at least 1 million years ago, possibly approaching 2 million. For most of that time, sleeping next to a fire was standard practice, not only for warmth, not only to cook, because a campfire broadcasts a signal into the surrounding dark that every large animal in range interprets immediately. Something that controls fire is here. Something that should not be tested. Move on. The predators received that signal before agriculture existed, before writing existed, before anything you think of as civilization had begun. 1 million years of selection pressure condensed into a single involuntary response. The smell of smoke activates an avoidance cascade in the nervous system, and the animal is already moving before the signal has finished processing. You figured that out before you figured out pottery, before you figured out farming, before you figured out any of the things you associate with human achievement. Fire first, the oldest survival technology you have, and one of the most effective because it speaks directly to something encoded in the nervous systems of every other large animal on the planet. Now, the biggest myth about predators, because popular culture has spent decades getting this entirely wrong. Predators are not reckless. This is so important, it changes how you understand every other part of this story. The image of the apex predator as a fearless, unstoppable killing machine is fiction. Large predators are extraordinarily careful about what they engage with because they have to be. A lion doesn't have access to medical care. One serious injury, a broken leg, a deep wound from a kick or a horn, damaged vision from a defensive strike, can mean a slow death from starvation or infection. Injuries don't heal at a clinic. They either heal while the animal somehow continues to hunt and eat, or they don't heal, and the animal dies. The numbers tell the story clearly. Lions hunting alone in daylight succeed roughly 17 to 19% of the time. Lions hunting in groups improve to around 30%. When targeting buffalo, large, powerful prey, the success rate drops to approximately 11.5%. These are the world's most effective large predators operating on their best days against prey they know intimately. They fail more than 2/3 of their attempts. Every engagement a predator makes is a survival calculation. Is the caloric value of this target worth the risk of injury? Is this prey familiar enough that its behavior is predictable? Is the probability of a clean kill high enough to justify the energy cost? A sleeping human fails this calculation in multiple directions at once. First, unfamiliarity. A predator is most confident attacking prey. It knows prey it has watched hundreds of times, whose defensive behaviors it can predict, whose blind spots and panicking patterns are encoded in its experience. It does not know how a human will respond. Humans are genuinely unpredictable. You might wake up screaming. You might have tools. You might have other humans nearby who will respond immediately. You might thrash in random, unexpected ways that could cause injury. Second, the posture signal. Humans standing upright on 2 legs read as inherently assertive to other animals. Standing bipedally is what gorillas do to intimidate. It's what bears do when they want to appear threatening. A creature that moves on 2 legs as its natural default mode sends a signal to other animals that is difficult to interpret as non-threatening. Even asleep, the human silhouette is unusual in a way that doesn't suggest vulnerable prey. Third, and most practically, why bother? There are almost always easier, more familiar options. A predator with a functioning territory has access to prey it knows, prey its body is calibrated to hunt. Going after something strange and potentially dangerous when a familiar prey animal is available nearby makes no survival sense at all. Here's something that almost never gets discussed, and it may be the most astonishing piece of this entire story. Your sleep is running a defense system you didn't design and don't consciously control. In 2017, researchers David Sampson, Alyssa Crittenden, Charles Nunn, and colleagues published a study in the Proceedings of the Royal Society B. They attached actigraphy sensors, devices that measure movement and rest states, to members of the Hadza, a hunter-gatherer community in Tanzania, living in conditions close to those of your evolutionary ancestors. They monitored the group continuously for 20 nights. What they found was extraordinary. Across all 20 nights of monitoring, the entire group was simultaneously asleep for a total of 18 minutes. Not per night, 18 minutes across 20 nights of observation. At any given moment during the night, a median of 8 individuals were awake or in a light enough sleep state to be responsive. One or more people were awake or in light sleep during 99.8% of all sampled time points throughout the 20 nights. The group never truly went collectively dark. Not once. Nobody organized this. Nobody was assigned to keep watch. It emerged automatically from the biology of the group. Humans of different ages have different sleep chronotypes, the natural timing of their sleep cycles. Young adults are night owls, falling asleep late and waking late. Older adults are early risers. Children and adolescents have their own rhythms. When you put a mixed age group together in a natural sleep environment, these overlapping chronotypes produce something that functions like round-the-clock sentinel coverage without any conscious coordination at all. Your individual brain is also less offline than you think during sleep. Human sleep cycles between deep, slow-wave stages and lighter stages, including REM, where the brain is remarkably active. During the lighter stages, sensory processing continues. Researchers have identified what they call the sentinel function of sleep. The brain keeps filtering environmental signals even at rest and flags anomalies for potential waking. An unfamiliar sound is more likely to break through into awareness than a familiar one. A change in the air that comes with something large moving nearby. A shift in the smell of the surrounding environment. These things can pull you toward waking faster than you'd expect. The humans in your evolutionary history who slept too deeply, who were completely unresponsive to nighttime threats, were more likely to not wake up. The lighter sleepers, the ones whose chronotypes contributed to collective vigilance, were the ones who survived and whose sleep patterns were inherited by subsequent generations. Human sleep was shaped over hundreds of thousands of years to stay light enough and irregular enough to maintain collective vigilance, even when no individual in the group was consciously trying to stay alert. The tent is not a dark box full of helpless targets. It's a biological alarm system with unpredictable firing intervals. Then there's the group response factor. Predators across the animal kingdom hunt for separation. A wildebeest in the center of a herd is far safer than one at the edge. A fish in the middle of a school is much harder to target than one that's been cut off. The fundamental predatory strategy across nearly every species is isolation, find the animal that's alone behind or separated from collective defense. A camp full of sleeping humans is a group. A group where, if one member wakes and vocalizes, others wake rapidly and respond collectively. The risk of a hunt collapsing into a chaotic group defense situation with multiple humans awake and active at once is exactly what predators are evolved to avoid. Now, honesty requires acknowledging the exceptions. None of this makes you untouchable. Attacks happen. They follow a consistent pattern. Almost every documented attack on resting humans involves circumstances that broke the normal rules. A predator injured and unable to hunt its usual prey effectively. A predator starving because its habitat has been destroyed. A predator that has been fed by humans or associated with human settlements long enough to have lost its inherited wariness. This happens disturbingly fast when animals are fed by tourists or come to associate humans with food rather than danger. The lions of Tsavo are the most famous case. In 1898, 2 male lions attacked and killed somewhere between 35 and 135 railway workers over roughly 9 months. The historical records disagree sharply on the number, and the legend grew in the retelling. Both lions were maneless, atypical for East African lions and likely a result of the heat and thorny vegetation of the Tsavo region. One had a severe dental abscess that would have made hunting large prey extremely painful. These were not representative of lion behavior. They were exceptions generated by exceptional circumstances. The Champawat tiger, responsible for an estimated 436 deaths in India and Nepal in the early 1900s, was found after its death by the hunter Jim Corbett to have had its upper and lower canine teeth on the right side broken. The upper in half, the lower to the bone, from what appeared to be an old gunshot wound. It could no longer hunt its natural prey effectively. Pushed by injury and then by the encroachment of human settlement on its habitat and prey base, it had turned to the only prey consistently available and physically manageable. The pattern across nearly every documented case is the same. Something broke. The normal calculation changed. The inherited caution was overridden by desperation, which means the rule holds almost universally wherever the ecosystem is intact, the predator is healthy, and no one has scrambled the normal signals. The last piece of this is the most genuinely remarkable. Your species has become so effective at making the natural world afraid of it that the fear is now reshaping entire ecosystems in ways no one anticipated. Ecologists John Landre, Lucina Hernandez, and William Ripple formally described this in 2010 as the landscape of fear. The idea that the mere presence of a predator, or in this case the perceived threat of humans, restructures how every other animal in an area uses space, when it moves, where it feeds, and how much it eats. The fear itself becomes an ecological force. William Ripple and Robert Beshta documented a version of this in Yellowstone after wolves were reintroduced in 1995. Where wolves were present and active, elk avoided certain terrain features, open valleys, riverbanks, not because they were constantly being hunted there, but because those spaces felt dangerous. The fear of predation, independent of actual predation events, changed elk foraging behavior, and because elk avoided those zones, willows and aspens grew above browse height for the first time in decades. The vegetation recovered. It changed the course of rivers. One predator's fear-inducing presence cascaded through every species in the ecosystem. In 2019, Chris Wilmers and colleagues at UC Santa Cruz published a study in Ecology Letters examining what happens to the entire food web when mountain lions avoid human-populated areas. When pumas withdraw from zones of human activity, deer in those zones face reduced predation pressure. Deer populations increase. The increased population overgrazes vegetation. Meanwhile, medium-sized predators, coyotes, bobcats, foxes, also reduce their presence in human-adjacent areas, which frees rodent populations to expand. Everything shifts. Every layer of the food web moves, and it moves because of a single signal radiating outward from one source: the fear of humans. You change the behavior of every predator layer across enormous areas of landscape without ever directly interacting with most of those animals. Just by being there. Just by being the thing that 2 million years of evolution told them to be afraid of. One species, one inherited fear, reshaping the entire living world. So when you're lying in a tent in the middle of nowhere, listening to the sounds of the dark beyond the nylon wall, and you feel that pulse of ancient anxiety, good. That feeling kept your ancestors alive. It's real, and it's old, and it served them. But the thing outside the tent? It's not coming in. It knows exactly what you are.